Morning. In this session, we evaluate how to prepare varied forms of sulfur. Welcome. As mentioned, sulfur is a naturally occurring yellow substance underneath the Earth's surface around 200 meters underground. It's obtained from there by the method of flask delivery or flask process, where three concentric pipes are lowered to reach the deposit. Hot water is passed through the outermost concentric pipe to melt it, and then hot compressed gas is passed through the innermost concentric pipe to compress the molten sulfur and force it upwards onto the surface through the middle concentric pipe, where it collects as molten liquid sulfur and soon changes into plastic form. What then are the varied forms of sulfur? Sulfur as an element exists in two allotropic forms as rhombic and monoclinic sulfur. While rhombic sulfur is octahedral and crystalline, the monoclinic sulfur is prismatic and needle-like. Now, in the event that we want to prepare what is known as the rhombic sulfur, we will need to have carbon disulfide. And then taking a sample of powdered sulfur, we will synthesize the two at high temperatures, and you will find that the composition will be rendered crystalline or rhombic in form. The rhombic sulfur is stable at temperatures below 96 degrees Celsius. It is crystalline and octahedral in shape. In the event that you want to prepare monoclinic sulfur, which we have said is prismatic and needle-like, we need powdered sulfur. The powdered sulfur is heated to melt, and then once molten, it is cooled gradually, leading to the formation of solid crystals of monoclinic sulfur. This is normally stable at temperatures above 113 degrees Celsius and less than 119 degrees Celsius. Now, as you have seen, powdered sulfur is important in both preparation of rhombic sulfur and monoclinic sulfur. How then do you obtain powdered sulfur? To obtain powdered sulfur, we take naturally crystalline sulfur, we heat it to become liquefied, and then we cool it gradually, and then it precipitates the powdered or fine-grained sulfur, referred to as powdered sulfur. Remember, when heating to form powdered sulfur, we must heat above the melting points of both rhombic and monoclinic sulfur, in this case 120 degrees Celsius and above. And then we cool it, and when it cools, the particles are fine-grained or powdered or crumb-like, and that is our powdered sulfur. How do we prepare colloidal sulfur? Colloids are simply threads. So colloidal sulfur again comes from powdered sulfur, where we heat it to make it molten, and then we drench it in water. By drenching in water, it means we add excess water, and then it forms threads. In other words, you take the sulfur, which is liquid, and deliver it into water, whereby it forms threads of sulfur, known as the colloidal sulfur. Plastic sulfur, on the other hand, simply involved the taking of any form of sulfur and melting it at very high temperatures, then delivering it on stable cold water in a trough. Now, the trough presumptively should be metallic, and then as you deliver it there, we expect it to form a solid crustal layer. The solid crustal layer is dense or thick. You will be required to puncture some holes on the surface to allow the excess gas building inside to escape. And then by using the sharp edge of a knife, you will be required to go at the sides to cut it round, trim it, and remove it as plastic sulfur. So as we have seen, sulfur exists naturally and in two allotropic forms as rhombic and monoclinic sulfur. Sulfur can be manipulated into varied forms into powdered sulfur by heating the crystalline and then cooling it, into colloidal sulfur by heating the powdered and then drenching it, into plastic sulfur by heating the solid sulfur into liquid and then delivering it into cold, stable water. What then are the other properties of sulfur? Sulfur can manifest into oxide forms. When you heat sulfur and a limited supply of oxygen, it will form sulfur dioxide, otherwise known as sulfur 4 oxide. It's a colorless gas which is of pungent smell. It is denser than air. It is soluble in water, and it does not support combustion. Number two, when you burn sulfur in excess oxygen, it will form sulfur trioxide with similar properties. Number three, sulfur can also form hydrogen sulfide gas. So how do we prepare hydrogen sulfide gas? Hydrogen sulfide gas, one, is a colorless gas with a rotten egg smell. This gas is truly unpleasant in its smell. It's colorless with rotten egg smell. It is denser than air. It is soluble in water. It's acidic and does not support combustion. How do we prepare it? To prepare hydrogen 1 sulfide, we need a metal sulfide such as iron 2 sulfide and a conc acid such as hydrochloric acid. When you synthesize the two, you get hydrogen 1 sulfide gas, the rotten egg smelling gas. Now, this gas, when dissolved in water, will become acidic in the format, it form hydrogen 1 sulfide acid. The hydrogen 1 sulfide acid is important in the sense that it can be used as a bleaching agent because when it decomposes, it forms the hydrogen sulfide ions which are oxygen deficient and bleaches by reduction. Number two, the hydrogen sulfide gas itself can be used as a fumigant, and when dissolved in water, it acts as a solvent. Thank you. That has been a description of sulfur, its few properties, and few other compounds.